Hello everyone. In our previous lecture, we understood the meaning of normal strain, which described the deformation in the context of change in length of the fibers oriented in a particular direction. But as the common sense suggests, that deformation is not always related with the change in dimension, but it is also related with the change in angle between different directions. So the engineering shear strain, which is the subject matter of this lecture, deals with the measure of change in angle as a measure of deformation. So let's see how it is defined. For that, let us again consider a body in the undeformed configuration. Okay, and let us consider two mutually orthogonal directions passing through a point. So suppose I consider this point and I take two mutually perpendicular directions which pass through this point. So this is one fiber which passes through this point, and this is another fiber which passes through this point. Okay, I call it point A, and let us take two more points on the fiber. I call it B1 and B2, and here I call it C1 and C2. So B1 A B2 is a fiber, C2 A C1 is a fiber, and both these fibers are perpendicular to each other. Okay, now this body undergoes small deformation, and this is a deformed configuration of the body. Deformed configuration. Now, after deformation, point A goes, say, here, and point B1 goes here. I call it B1 prime and A prime. Then, since it is a small deformation, we know that a straight line remains a straight line with the same material points. So if B1, A, and B2 were on a straight line, then B1 primed, A prime, and B2 prime must also be on a straight line. So suppose this is B2 primed, okay? And suppose C1 goes here, I call it C1 primed. Then again, C1, A, and C2 were on a straight line. So after deformation, C1 primed, A primed, and C2 primed will also be on a straight line. So this is, suppose C2 prime goes here. So before deformation, the two fibers, the angle between the two fibers was 90 degree, but after deformation, the angle between the two fibers have changed. Okay, now let me first write the definition. So the engineering shear strain is defined as the change in angle between two originally orthogonal directions in the body. It is measured in radians. Okay, now see the definition. It is defined as the change in angle between two originally orthogonal directions of the body. And we have seen that change is always final value minus initial value. Okay, so what is the final angle between the two fibers? It is angle C2 primed, A primed, B2 primed minus pi by 2. Should I write this, or should I write angle C2 primed, A primed, B1 primed minus pi by 2? Because the initial angle, no matter which quadrant you take, suppose I call this as first quadrant, second quadrant, third quadrant, fourth quadrant, then this is the first quadrant in the deformed state, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant in the deformed state. So the angle between the two fibers, no matter which quadrant you choose, is pi by 2. But in the deformed state, if you choose the angle in the first quadrant, which is this, then the engineering shear strain is negative because the angle is decreasing. But if you choose the angle in the second quadrant in the deformed state, which is C2 primed, A primed, B1 primed, then the engineering shear strain is positive. So this quantity turns out to be negative, and this quantity turns out to be positive. So there is a confusion. Which expression should we choose? Okay. So in order to avoid such confusion, what we do to avoid such confusion, we first define a coordinate system. Okay, what does it mean? It means that suppose these were the two orthogonal directions passing through point A, then assume that A is at the origin and you choose the positive direction. So suppose I choose this as the positive direction, say M. This is plus M direction. And I choose this as the plus N direction, the positive N direction. Okay, then this becomes negative M direction, and this becomes negative N direction. So in order to measure the engineering shear strain, we always see how the angle between the two positive directions changes. To measure and report the engineering shear strain, we see how, or we see, or we measure the change in angle between the two positive directions. Okay, that is plus M and plus N directions. Okay, and by convention, although I am saying that we measure the change and change is always final minus initial, but we always find pi by 2 minus final angle between the two positive directions, plus n and plus n. And for this, the symbol is gamma. Gamma is used for engineering shear strain, gamma, and the two directions are m and n. So here we are using two subscripts. Please note that we are using two subscripts. Okay. So it is pi by 2 minus the final angle between the two positive directions. Now, this quantity may be positive or may be negative depending on which direction you choose as the positive direction and which direction you choose as the negative direction. For example, suppose this is one direction and this is another direction. In the first case, and suppose these are the two directions, orthogonal directions, and it deforms like this. It deforms like this. Now, in case 1, I choose that this is positive m direction and this is positive n direction. Okay. So the initial angle was pi by 2, and suppose this angle is, because we have to measure this angle, because it is the final angle between the two positive directions. So this is the positive end, the fiber along the positive end direction in the deformed state. And suppose this is angle 3 pi by 4. So how will you write gamma mn? So it is pi by 2 minus 3 pi by 4, which is minus pi by 4. Okay, but in case 2, this is the same fiber. These are the same fibers in the deformed configuration. Okay, but now I choose this as the positive m direction and this as the positive n direction. So initially the angle between them was 90 degree. Since this was 3 pi by 4, this is pi by 4, and we have to measure, we have to take this as the final angle between the two positive directions. So now we will write gamma mn as pi by 2 minus final angle between the two positive directions. So this was first quadrant, this was the second quadrant. Our positive m and positive n direction were constituting the second quadrant. And in this case, the angle between them is pi by 4. So the strain is pi by 4, engineering shear strain is pi by 4, which is positive. And here it is negative. Okay, so it implies that the sign of shear strain depends on the coordinate system. Please remember that. The sign of the shear strain depends on the coordinate system that you choose. Okay. Thank you.